Hello IB, how did you go with 7 part A on the expansions of those binomial terms? Hope they went well. So today we're going to look more at the coefficient, that number in front that we've seen appeared as Pascal's triangle. So here we are, Pascal's triangle, just a quick review. So remember, we're looking at a binomial being expanded to the power of n. When n is equal to 0, we just get power of 0 makes it 1. When n is 1, we just get a plus b, so the coefficients were both 1. When n is equal to 2, that expanded as a squared plus 2ab plus b squared. Our coefficients were 1, 2 and 1. And then when we had a power of 3, we saw the coefficients were 1, 3, 3 and 1. Today I want to look at a little bit more detail on this. So when we come up with our coefficients, what are we exactly doing? So what I've done here is I've got a binomial to a power of 3, which means we've got the 3 terms being multiplied. And we want to look at how many different ways you can make or combine the parts of this binomial, each of the binomials being multiplied, to make the terms that we end up with. So if we start off looking at our a cubed, how do we get our a cubed? We can see that to make that, we would have had to, I'm going to come up here, hold it, working a different board here. We would have multiplied a times a times a. So in other words, there's only one way we could have made our a cubed. What way? All right, to get our a squared, let me just rub those ones off so we don't get confused. That's a big rubber. Okay, so now to get our a squared, to make that that could have come from a times this b. That would have given us a squared b, or, just to move that one, we could have done a times b times a, or we could have done, let me get a different coloured pen here, we could have done b, hold it, my pen's not moving, there we go, we could have taken this b and that a and that a, and I'll put the other one in red. We could have done this a and this a and that b. So in other words, there were 3 different ways we could have made our a squared b, because the b could have come from the 3 different binomials. So for this term, 3 ways to combine our a's and b's. We could do the same with a and b squared. In other words, we could have taken this a, let me just get here, we could have taken this a and then this b and this b, or we could have taken our a from here, and on the 3rd time we could have taken the a from here, so from this one here. So it's the same story, that there were 3 ways, there are 3 ways that we can make our a b squared, and there's only one way we can make our b cubed, because we had to take the b from each of them. There's only one option. So basically that's what our numbers in front are telling us, how many different ways we can combine the different parts of our binomial to get the overall binomial, the overall term. So the numbers in Pascal's triangle, we refer to them as a binomial coefficient. They're the numbers that go in front of our terms, and we can write them in different ways. There's 2 notations we're going to be using. This first notation, where we've got n and an r inside the brackets, and you'll remember seeing something similar to that when we did transformations of functions, but this will mean something different. The other way we can do it is writing it with this notation, what we call our NCR, and that's another way you'll see it, but I tend to write it with the n and r on opposite sides, but you'll see both. So n, remember, refers to the power of the expansion, what power we've got. The r is going to refer to a position along that row in Pascal's triangle. The c stands for combination. So how many ways we've combined the terms. Another terminology is to say we want to choose from n things r of that term. So if we've got n binomials, we want to choose a certain number of a's or a certain number of b's. So let's see how this relates to our Pascal's triangle. So we remember that for our Pascal's triangle, this is our n equal to 0, here's our n equal to 1, this is our n equal to 2, and our n equal to 3, etc., all the way down. So that we know. Now what we want to do is, in here we picked 3 A's, but we didn't have any B's. There were like 0 amounts of B's. So this corresponds in our triangle here for no B's is going to be any of these terms that we form. Just finding a different colour here again. Let's just go green. So we always get a coefficient for that first term of 1. So this line here always is our first term where we've got a cubed, or if we had n is equal to 4, it would be a to the 4th, and there were no b's in it. And so this is our everything in that row means we've got no b's, r is equal to 0. The next diagonal coming down is going to be where we have one of the other part of the binomial. So that corresponded to a squared and b to the power of 1. So let me go red with this one. So these are the coefficients for the next term. So we've got, this is what corresponding to our first term. This is our second term. Coefficient was, in this case, we had 3. Then on this next row here, let's get another colour. Let's go yellow. So this row here, this is where they all have 2 of the second term. So it was like ab squared. And then we saw in our cubic, the last one is where we've got b cubed. We'd have 3 of them, and there were no a's. So the r refers to how many of that second part of our binomial, how many b's there are. So this is saying that we can see that along the row we've got 4 terms. So another way we can write these, like we do for this first row here. Let's go blue again. So for n equal to 3, we had, I can write it like this. We had a power of 3, and our first term was where there were no b's in it. We could also write that as 3c0, and that was equal to 1. The next term, so that's when we had our a cubed. Our next term was 3, 1. So that's 3c1, and we saw that was equal to 3. That's when we had a squared and we had 1 lot of b's. So we're sort of jumping a little bit ahead into the next section, but this 1 is matching the 1 down here. Alright, let's go back to the blue. So if I want, I'll do that one in a moment. This one here in black, I'll go black pen here. This is our third term, but this is r equal to 0, r1, r2. So this black one here is going to correspond to what's the power? That's going to match that number here. So n is 5. R0, R1, R2, so this must be R2. Another way of writing that is 5C2, and that is equal to 10. All right, so 12C7, another way of writing that would be, a power of 12. R is 7, so this is corresponding to the, R is 7, we've actually got the 8th term for our binomial where n is equal to 12. Okay, so that's, we've written up the top here. Needs some red. This corresponds to the r plus 1th element in the row. So when r is 0, that's our first term. R is 1 is our second term. R is 2 is our third term. So when I have something like 12C7, I've got the 8th term of some binomial which has got a power of 12. A couple of things to note. NC0 is the same as NC1, it is 1. So that's the outside of our Pascal's triangle. They are always 1, around there and down the outside there. The other one, so an example would be, where are we? Pen. If I had, pick a number, 13, oops, sorry, got phones going here at the same time. 13C0 is the same as 13(1), and that equals 1. And NC1, that's the second term. Note that always matches the actual power, so that's the same as our n value down both sides. So that's an important one to remember. So NC1 is always the same as NCN, n minus 1, one number less, and that is always equal to n. So in other words, if I had 13(1), that's the same as 13C12 equals 13. And that's going to be an important one for you to remember. But we'll work with that more. We can actually calculate these using factorials. So a binomial coefficient can be calculated using a formula involving factorial notation. If you haven't come across factorials before, that's not a problem. But basically, for anything greater than 1, n factorial is the product of the first n positive integers. So n factorial means n times n minus 1 times n minus 2 all the way down to 1. And there's that little exclamation mark. It's on your calculator as well. So for 5 factorial, that means we're going 5 times 4 times 3 times 2 times 1. And if you multiply that out, that gives us 120. So that's what 5 factorial means. This is only made for, this rule works for n greater than or equal to 1. We actually need to know what 0 factorial is, and that is equal to 1, but we won't go into the reason for that at the moment. So to calculate our binomial, we can use this rule here. So NC3 is equal to n factorial divided by r factorial times n minus r factorial. So these are all factorials. So let's do that for 5C2. So that means on the top we want 5 factorial divided by 2 factorial times 5 minus 2 factorial, which is going to be 3 factorial. So that's going to be, if we write that out, we've got 5 times 4 times 3 times 2 times 1, all divided by 2 times 1 times 3 times 2 times 1. what you're going to find is that these, you'll always get parts that cancel. So now we're left with 5 times 4 is 20 over 2, which, bit of space, equals 10, which is what we found earlier. We can also do this with our calculators. So if you go to your GDC, then in here, I'll show you how to set that up. You can just type in NCR using the keys and then do your brackets, and in there you're going to put 5, 2, and that gives you 10. The other place to find it is if you go to your catalogue and go down to N, and there's the NCR, so you can choose that and put in your 5, 2. So 2 ways to get that factorial value. So if you're in a calculator paper and you've got a really big number, use your calculator, don't draw up Pascal's triangle. So that's how to work out your coefficients using a factorial notation. Thanks for listening, and if you've got any questions, bring them to class. Bye for now.